Doctor, can you tell us, how does UV work as a disinfection technology?
Well, ultraviolet disinfection, or more specifically, UVC disinfection, is able to inactivate viruses, molds, bacteria, and the technology has actually been used for nearly a century. When I was a child, it was much more common to see ultraviolet lamps in various disinfection rolls in public bathrooms and things like that. But it came out of use largely because there were developments of polio vaccines and other vaccines that made it unnecessary to pay so much attention to disinfection. And of course, in the last year, it's suddenly become the new thing, but it's not a new technology. For the most part, the application has been currently used in hospitals and intensive care units, and particularly in biological research laboratories where they need to disinfect particularly airborne bacteria or viruses. It's really one of the only practical ways to disinfect air.
And Dr. Sliney, we've always been told to wear sunscreen to avoid the harmful UV rays of the sun, but how does this type of UV radiation cause risk to human health, and how can we mitigate that risk?
Right. Well, there's sadly a lot of misinformation about the potential risks. It can be very safely used and is widely used for upper air disinfection, where the UV is maintained just in the upper parts of the room. And that's particularly valuable when you have a high ceiling. And then the people at lower levels in the room are not exposed to anything hazardous. But the risks are normally just acute. That is, you can cause an inflammatory response in the skin that we call erythema, or reddening of the skin. And it's a much milder form of what we'd experience if we had a real sunburn. And the reason for that is that UVB from sunlight penetrates deeply down to the germinative layer of the epidermis. And that's the causal factor for skin cancers. So it comes as quite a surprise to a lot of basic biologists that UVC, which are shorter wavelengths that are not in sunlight, they're blocked by the upper atmosphere, that those more energetic rays can be much safer than UVB. And the reason is that almost all of the energy is absorbed very, very superficially. And the penetration depth to that germinative layer is like 1/100th of UVB. So to most people's surprise, UVC is far less carcinogenic, far less of a risk for delayed effects. Now, the skin inflammatory response is unpleasant because it's itchy, but it's a very mild reddening, and it doesn't last nearly as long as a true sunburn from those more penetrating sun rays. Now, the effect on the eye, though, can be rather painful, and the biggest safety issue is to make sure that people are not exposed above safe, recognized exposure limits. And fortunately, UV from overhead, as from the sun, normally doesn't reach the outer surface of our eye, known as the cornea. And we don't have this problem unless we have a very reflective terrain like snow. So the effect known as photokeratitis is also known locally as snow blindness, because if you don't wear ski goggles, you can experience that effect. is rather unpleasant that night. And it's also known as welder's flash. And the same effect as snow blindness, but normally welders are always protected. And so in actual use of UVC, we have welding arcs and we have germicidal lamps. And in both cases, if they're not protected against, one can have that unpleasant welder's flash experience. But proper installation of germicidal UV lamps in a setting can be perfectly safe.